Hello everyone, and welcome to Scientific Methods 1, where we are going to begin to discuss how we're going to analyze labs in here. So I just kind of want to go through an example, and we'll talk a little bit about some of the things that we need to do to begin to analyze a lab. So here's our example lab. Peter Popper plants prodigious plots of pea plants. Say that 5 times fast. And of course, when you plant prodigious plots of pea plants, and over time, they grow. Oh, look at that. They grow. So every week, he measures how tall his pea plants are, and he records the results in, of course, a data table. Now, if this is the lab, the first thing we need to identify is what variables are being tested. Right? Kind of the obvious one is he measures the height of his pea plants. So height is one of them. But the other one is here every week. Right? And week is a measurement of time. So it's height and time. Time can be a tricky one because sometimes you say time, and sometimes you just give an indication that that's what you're doing. Right? Every week he makes this measurement. Now you might remember that there are 2 different kinds of variables when it comes to experimentation, something called an independent and a dependent variable. So which one of these is which? Well, first of all, let's think about what an independent variable is. Right? I mean, it's the independent one, right? But what does that really mean? Well, I like to think of it as the one that you control, the one that's controlled by the experimenter. You chose it. You chose it. So did you choose the height that the pea plants were, or did you choose when you made the measurements? Well, of course, you chose when you made the measurements. And so that's the time. So in this case, time is our independent variable. That will often be true, but not always. The other variable is, of course, the dependent variable. It literally depends on the independent variable. Right? When you change the independent, you get a change in the dependent. And in this case, that would be the height of the pea plants. So independent variable is time, dependent variable is height. You're going to get some practice in a concept builder in deciding what is independent and dependent. So let's say he makes his measurements, and here we go, right? Every week goes by. They start out their seeds, so they don't have any height. Right? After 1 week, they're 9.5 centimeters tall, and so on through 6 weeks. So the next thing we want to be able to do is to look at that data and say, well, is there a pattern? Well, you can definitely see that as the weeks go by, the pea plants get taller. But is there a pattern to it, a predictable pattern? Hard to tell by looking at raw numbers. So that's why we often make a graph. So here are some characteristics of a good graph. Good graphs have a title, right, so that anybody looking at the graph knows what's being graphed. Now you can make some, sort of fancy title, Peter Piper's prodigious pea plants or something like that. I guess Peter Popper's prodigious pea plants. Right? But more generally, if you want to be scientific about it, right, it's usually just dependent variable versus independent variable. Right? So in this case, if these are our axes, right, our title might be something like height versus time. Not going to confuse anybody, maybe not that exciting sounding, right? But at least it's accurate. Right? Height versus time. Notice y versus x, dependent versus independent, is the way you write it. Next characteristic of a good graph. You need to label your axes. Otherwise, somebody looking at your graph doesn't know what you're graphing. And not only do you need to label the axes, you must use units. Right? Numbers without units don't have the same meaning. We need context. Right? It's part of the language to use the unit. In general, there's a rule of thumb here, a convention, if you will, that the independent variable gets graphed on the horizontal axis, while the dependent variable gets graphed on the vertical. So in this case, we would graph time in weeks, notice the units, on the horizontal axis, and height in centimeters on the vertical axis. Now, do we always have to put independent on the horizontal and dependent on the vertical? No. It's a convention, all right? It's just generally done that way. There are times when we're going to violate that convention, and I will let you know when we're going to violate that convention. It's usually because I want a certain meaning to our slope, right? And maybe we can't do the lab in a way where we control the one variable and measure the other like we can here. right? And so we end up having to kind of flip things around. But I'll let you know when that needs to happen. Next thing you need is to scale each axis. Now, the two scales don't have to be the same, but they do have to be consistent on an axis, which means if your first line is 1 week, well, then your next line better be 2 weeks, and your next line better be 3 weeks. Right? You can't go 1, 2, 3, and then 6, 9, 12, or something like that, right, on one axis. That gets very confusing and very hard to read. But that doesn't mean if every line here is 1 week that every line here has to be 1 centimeter. Right? Every line here could be 10 centimeters. That's fine. Just be consistent. And you want to make your axes scaled so that your data is big. It's hard to see a pattern if your data is all smushed against the corner or smushed against one of the axes. Right? So you want to spread it out. Now, when we use the computer to graph, it's going to have something called auto scaling that will do this for you. Right? But if we're making our own graph, we do it by choosing a scale that helps us fill things. Basically, you should take your highest point and kind of use that as a guide to decide your scale, right? So that your highest point is up here in the corner somewhere. And then we tend to draw scatter plots in here. Okay? On occasion, we might use a bar graph, but we tend to draw a lot of scatter plots, which means you graph the dots. Okay? You don't have to connect the dots. In fact, generally, I don't want you to connect the dots. You don't have to write the coordinates next to them. That's what the data table's for. The coordinates are all right here. Right? I just want you to draw the series of dots, including if there's a 0, 0, put a 0, 0 down in the corner. After that, we're going to do something a little more complex to see the pattern, okay, and to analyze the pattern. But that's going to be part of scientific methods too. So, I hope you enjoyed this little introduction, especially the characteristics of good graphs.